Okay, so you might think that writing down something like "it is red binary code with missing pieces" sounds like a pretty solid descriptive way to explain corrupted data on your Cambridge 0478 computer science exam. But digging into the actual Cambridge examiner reports reveals a pretty harsh truth. Writing that earns you absolutely 0 marks. None. Today, we're exploring the massive gap between what students guess is right and what actually secures those top grades. We are going to see exactly how these examiners think. Okay, let's dive into this. If we look at these two approaches side by side, it reveals exactly what goes wrong for so many students. On the left, we have a classic textbook student answer. I mean, it's visual, it's generic, but it costs crucial grade boundaries because it just completely lacks technical depth. It's really just describing what a human sees on a screen. But on the right, that is the examiner's dream. Data corruption occurred during transmission, altering the binary sequence. It's precise. It targets the underlying mechanism of the computer itself. So, in this explainer, we're going to decode exactly how you can consistently build analytical answers just like the one on the right, no matter what kind of question gets thrown at you.
So, topic 1, the hidden exam trap. We're talking corrupted data and the binary foundation. Listen, to survive both Paper 1 and Paper 2, you absolutely have to understand the fundamental traps hiding in plain sight. When a question asks about corrupted data, it's not just asking about a broken file or a glitchy image. It is fundamentally testing your grasp of how computers handle binary at the absolute lowest level. If you don't understand that underlying binary foundation, your answers, well, they're always going to sound like fluff to an examiner who is grading literally hundreds of papers. They are actively scanning for structural understanding, not just a visual description.
All right. Moving into Section 1, decoding binary and data. Basically, what the examiner actually wants. You know, computers and computing devices are absolute powerhouses, right? They're capable of processing millions of pieces of info every single second. But to explain that to an examiner, we have to start with exact definitions. The information used by a computer is simply called data, and the code that computers and machines actually use to process that information is binary. Nailing these precise definitions early on is exactly what secures those easy first marks on an exam. If you blur the lines between data and binary, the examiner is just going to assume you don't understand the foundation at all. And there's this quote that just hits the nail on the head. All data that a computer is required to process has to be converted into binary in order to be understood. It brilliantly illustrates the core rule of computer science. Every single input you can think of, whether we're talking about a text message, a high-res photo, a video stream, or some complex software command, it must be entirely broken down into machine code. There are absolutely no exceptions. The computer doesn't see a red missing piece on a screen. It only sees a disrupted sequence of basic binary values. Recognizing that translation process, that's what separates an amateur from a top-tier student. Which actually brings us to this incredibly important number right here, 2. It's the absolute foundation of the relationship between the decimal or denary number system we use every day and the binary system the computer uses. Binary is a base 2 system. It relies entirely on just 2 states, 0 and 1, true or false, on or off. The entire digital world is built on this binary simplicity. If you keep this base 2 rule in mind, even the most complex exam questions suddenly become way easier to manage, because everything ultimately just reduces down to this pair of digits. Now, you might be wondering, we know what binary is, and we know data needs to be converted into it, but what single, secret element changes an exam answer about binary from an average C-grade response to a flawless A-star grade response? It's a massive difference, right? Well, stick around, because I'm going to reveal that exact examiner clue that changes the outcome completely in just a few minutes, but first, we really need to understand the framework that makes that clue so obvious. So to build that framework, let's jump into Section 2, Logic Gates in Action, focusing on Boolean logic and truth tables. We're moving from pure theory to a high-stakes practical application for Paper 2. Imagine this classic exam scenario. A security light outside a house comes on after 6 p.m. or if it is dark. Read that carefully. When you're faced with a scenario-based question, the examiner is actively testing your ability to pull the exact nouns provided in the prompt and translate them into pure logic. Don't invent your own scenarios. Don't use synonyms. You have to use after 6 p.m. and it is dark. Sticking to their exact phrasing proves to the examiner that you are answering their specific scenario. Now, what's really interesting about this slide is how we literally bridge the gap between human language and computer language. We take the real-world condition, say after 6 p.m., and we convert it into a Boolean value, true, yes, or positive. Then we take the final step and convert that Boolean value into our foundational binary value, a 1. We do the exact same thing for the condition it is dark.
We are literally translating physical reality into ones and zeros. And this step-by-step translation is exactly what the mark scheme rewards.
And following that logic, you can see how it builds out our resulting truth table. Look at the inputs on the left and our output on the right. Notice how the output, the light coming on, triggers a 1 if either condition is met. If it's 0 and 1, the output is 1. If it's 1 and 0, the output is 1. And crucially, if it's after 6 p.m. and it's dark, so a 1 and a 1, the output is still 1. This is the classic predictable behavior of an OR logic gate.
But hold on, because there is a massive trap hiding here that pops up in examiner reports all the time. You absolutely have to know the technical distinction between a standard OR gate and an exclusive OR gate, known as an XOR gate. A standard OR gate is true if A is true, B is true, or both are true, just like our security light. But an exclusive OR gate, it returns true only when A or B is true, but not both. Mixing these two up is a guaranteed way to lose easy marks on tricky Paper 2 questions. Always verify if the both condition applies.
All right, that brings us to Section 3, the examiner's secret framework. Let's look at building the perfect answer. So the crucial point is, this 5-step answer upgrade template is your golden ticket. This is exactly what the examiner reports point to if you want to guarantee maximum marks systematically. Step 1, provide the exact definition. Step 2, explain the technical mechanism behind it. Step 3, apply it directly to the scenario example given. Step 4, state the consequence or outcome. And finally, Step 5, wrap it all up in precise examiner wording. And remember, do not repeat the same idea twice. The mark scheme is ruthless. 1 mark normally needs 1 distinct technical point. This 5-step process ensures you hit every single requirement.
Now for Section 4, upgrading to top marks. It's time for a quick pause and solve challenge.
Okay, so here is that flawed 0-mark answer from earlier. The data is corrupted and has red binary code with missing pieces because of a hacker. I want you to literally pause this explainer right now, look at this generic fluff, find the errors, and try to rewrite this answer in your head using the 5-step framework we just talked about. Think deeply about the definition, the mechanism, and the consequences. Give it a shot. Okay, let's see how you did. Check out the mark scheme safe answer on the right. Notice how we ditched the vague fluff for precise technical language. Data corruption during internet transmission gives us the exact mechanism. Alter the binary sequence, 0s and 1s, grounds it firmly in our foundational definition. And rendering the file unusable gives us the clear consequence. By replacing visual fluff with technical reality, you instantly secure full marks and prove to the examiner that you actually understand the underlying system. And hey, that brings us right back to that question I asked you earlier, the secret element that changes a C-grade answer to an A-star grade answer. It's scenario nouns. Yep, scenario nouns. Generic answers are inherently weak. The secret to the A-star is always tying your technical mechanism directly back to the specific nouns provided in the question scenario. If they give you a specific network, a specific sensor, or specific security light, you must use those exact words in your answer. It bridges your theoretical knowledge to their practical test. So, you've mastered binary, logic gates, the whole shebang. You've got the 5-step framework to write perfect answers. But let me ask you this. What about the fatal errors still hiding deep within the examiner reports from past years? The invisible pitfalls that consistently trick even the smartest students into dropping a whole letter grade. You know the strategy now, but to truly bulletproof your grade, you've got to know exactly what those traps look like before you sit down for the test. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Seriously, you absolutely need to click on our next explainer right now, where we decode the biggest examiner report mistakes and show you exactly how to avoid them. See you there.